there's going to be instances where the robot's going to have to slow down. So we take kind of like that in there, and we come up with an estimate of a fleet. In this instance, we said 6 are needed for this application. Put together some budget pricing. It all looked good. Customer wanted to take it to the next step. So what we do is we simulate, what I mentioned before. So this is an example of how the simulation works. Based on all that information that we do, one of our robotic application engineers, they create orders, and they put those orders into the simulator. This application, we proposed 12 LD250s. So each robot is online. We're seeing here all the jobs that he created. The blue dots are the robots completing the jobs. The checked ones are complete. This with the green is robots and jobs in queue. And so we run it. We run it for a period of time. Watch how the robots react, how they can navigate the environment here. This is a DXF drawing of the actual floor plan of the facility. We can also do it off of an actual map scan if you don't have a CAD drawing of your facility. So we watch how the robots run, see if there's any problems with intersections, and there were with this one, so they did preferred lines here. You can see those 2 gray boxes. It's telling the robots to bias to the right when it's in there, to stay on a course. We call it selective autonomy. You can make the robots act like an AGV, so it can be autonomous till it gets to a certain area. If it has to act like an AGV, it will. But as an AGV, it follows a line like a bus. It doesn't stop. If there's an obstruction, it's going to wait until that obstruction's moved. Once it gets past there, it becomes autonomous again. And what it's doing, it's delivering the conveyor inputs here. This is 2 palletizing systems. Now, we didn't simulate that part. They've got 2 of our 1,500 kg robots taking built pallets from the palletizer. Each one's a 6 pallet nest, and there's 2 of them. And then taking them to the stretch wrapper, and then from the stretch wrapper to the warehouse. But this was the mission critical right here. It's making sure that these robots can take the cases from the injection mold machines on time, within the cycle, the machine cycle times, and how many cases the machine was filling an hour, and making sure it gets to the palletizing system. Once we do that, we usually provide you with some metrics. How many robots, were they always available? Were robots not available at certain times? Where were their hang-ups? What was the average speed of the robots when it was running through the simulation? Maybe it didn't match with the FleetManager, but the result of that is validate the system and let you know exactly how many you're going to need.